So my name is Jeff Fletcher. I am almost the head of innovation at Internet Solutions, but my boss is here, so let's not tell him that he hasn't got the memo just yet. My job is to look at new products and services that we're going to build and new technologies over a 2 to 10-year time horizon. And specifically, we need to take the product, take the technology, peel away the marketing, peel away a little bit of the hype, and kind of have a look at what the core thing is and understand, is that specifically useful, and is it something that would apply to our client base. So one of the ones that I've gotten is big data. And if you think data lake is one of those nebulous terms, big data is wonderful for that. It's what we call a Smurf word, which means it means a lot of things to a lot of people. If I was talking to you about transport, I could be selling cars, bicycles, skateboards, oil tankers, tandem skydiving. They all fit into the mold of transport. And big data has a similar problem. So from our perspective, we've looked at it to say, how do we bring something to market? How do we understand the market? And technically, what are the bits and pieces that we need to look at to try and understand how we can bring something through to it? And that's our journey today. So I'm going to start by issuing, maybe a challenge is a strong word, it's not dueling at dawn, but a lot of people are pointing to this particular study, which is from the IDC. It's the Digital Universe Study, and it talks about the growth of storage over the world over the next few years. It's one of those lovely exponential graphs that shows things are going on a nice exponential trajectory. And what I've put in there is, that white line is what I call the information line. I think that the rate of increase in data does not equal the rate of increase in information. And to give you an example, if I have, in 2006 was when Blu-ray came out. One of the first movies that came out was The Fifth Element. And The Fifth Element, if I have the DVD version in this hand and I have the Blu-ray version in this hand, I haven't changed the informational content. The plot is the same, the characters are the same. I've just increased the amount of storage that it takes for that thing to occupy the digital universe. And if I have 2 copies of it, my backup copy, definitely my legal backup copy, I would not have downloaded that. I'm storing this in the same digital space. It's not actually adding more information to it. So there is that trend that people are pointing to, which I don't think is necessarily an indication of the underlying information change. At the same time, predicting something in terms of an exponential graph, we can go back in history and have a look at similar predictions to see how they went. Now, one of the things about talking later in the afternoon is that all the good quotes are taken. So I figured, how can I get a quote that no one else has used? The Bible. So in researching this, I found a quote that says, "Of making many books there is no end, and of much study wearies the body." And it's so true. My daughters are busy doing exams, and they're very weary of studying. So if we take 2 specific instances of predictions that went wrong. The first one was in 1894, I think it is, the Times of London predicted that by 1950, the streets of London would be 9 feet high in horse manure because of the rate of change or rate of adoption of the horse-drawn carriage as a form of transport. Clearly, if you've been to London recently, it's not the case. And the other one is Fremont Ride in 1944 predicted that in 100 years' time, the Yale Library would have over 200 million volumes in it, based on the rate at which people were writing new scientific journals. And it would occupy over 6,000 miles of shelves, requiring 6,000 people to look after it. And that made me think, could I look after a mile of shelves? I think I could. I think it would be a fun job. So those 2 particular instances show that there's often an escape clause. Some kind of technology comes in and breaks the exponential curve. That being said, we are seeing a reduction in the cost of storing things, and we are seeing more things to be stored. So from our perspective, we're seeing an increase in the utilization of data storage and information storage. So we have to look at it from our perspective. How do we see the market? So we see the market in the view of the cloud, because we host infrastructure. We keep servers, we keep things in place online for you. And we start at the bottom with the machines that run this. Then there's the platform that sits on top of it. And then there's the applications that go above that. On the left is the data that comes in. Did I get that right? I used my right hand, but it's the left-hand side of the screen. It's a bit like racing a car, I would think. So you have to collect data. You've got log files, you've got social data, you've got Wi-Fi analytics, you've got GPS data. All of that information needs to be funneled into this infrastructure that sits in the middle. And then on the other side, you have the useful part, and that's the data services. That's the predictive analytics, that's the visualization, that's the machine learning algorithms. Those are the bits and pieces that, as a combined ecosystem, makes business intelligence and big data useful. But we have to start somewhere. We have to start with what we can do as a service provider. So what we do in our team is we build what's called a minimum viable product. And a minimum viable product is the shortest, smallest unit of usefulness of a product that someone will use. So we can't start with something that is a portion of it that's not going to be useful to someone. We have to start in the middle. We have to start not in the middle, but like in the core. And we have to compound, and we have to build, and we have to layer on as we go. And this is an iterative process that we do with our clients, because we test something. We don't necessarily know what people want. We have to start slowly. We have to start experimenting. We have to start building and as we go. So, spoiler alert, this is what it looks like. I'm going to take you through now some of the technical decision processes that we had to make. And if you're coming to the workshop tomorrow, this is what we're loading up, and this is what we're testing with. It's about a 95% beta, so there are 1 or 2 decisions that we're still making as we go, but that's what it looks like. So the starting point, it runs Hadoop. Hadoop is the winner in terms of big data. We've spoken to our clients, and they see as a storage technology, as a data processing technology, big data and Hadoop are synonymous. The history of Hadoop, it came out of Google trying to solve a particular problem, which was keeping a copy of all of the internet and searching it at the same time. The internet is quite big, and I don't know if you ever marvel at this, but I marvel at this all the time. It's faster to search the entire internet than it is to find that one file that I meant to send to someone yesterday that just appears to have disappeared off my machine. So the 2 components of it, and Google published the technical papers on these in around 2003 and 2004. The one is called the Google File System, which talked about how they used a cluster of low-cost machines and stored copies of the internet on it and replicated across in different places to make sure that there was a redundancy. And then MapReduce. And the MapReduce is the ability to do the search across all of these machines, to actually take the query and run it across a whole bunch of machines, aggregate it, and bring it together. They're interesting papers to read, unless you're not interested in this industry, in which case they're great to help you sleep. So from there, in 2005, some engineers who were working at Yahoo, and Yahoo used to be a search engine, remember them? Yep. They were working on something similar, and they took the work that Google had done and created Hadoop. Hadoop, at its core, is the Hadoop file system, which does the data replication, and MapReduce. And over time, it has grown into a big ecosystem of different projects and different Apache Foundation source code archives that allow you to do different things. It's niched, it's focused, it's broad in that it can provide a lot of capability into a lot of different places. And as I said, our clients see Hadoop and big data as synonymous. So that's our choice. The other question we get asked is, okay, well, if you're doing Hadoop, why didn't you choose this particular thing? And it comes down to the fact that there's pre-awareness. A lot of clients will know about Hadoop, and it provides a journey for you to get to a lot of those things. So a lot of what we have there is very niche. It might be just an in-memory database, or it's a graphing database. It's not as applicable as broadly. So Hadoop fills that particular requirement and allows us to migrate. Then you have to choose a distribution. So what a distribution is, all these very clever open source engineers tend to write stuff that works well but is ugly. So the companies that make distributions put wrappers on top of it. They put an installer onto it, and they'll put a nice graphical user interface over that to make it more accessible to a less technical audience. And we had to choose one, and we had to make our choice based on market awareness, so people need to know that these are particular leaders in the space. It has to be based on technical competence, so they must also be good at what they do. And then there's support, pricing, and local presence. Because it may be open source, but it doesn't mean it's free. You still have to pay for the cost of the continued development. You still need some support. So based on those criteria and talking to a lot of these distribution providers, we've chosen Cloudera and Pivotal as the 2 that we're going to be going with. Interestingly, if you look at the fragmentation of Linux distributions, if you go back to 1991, I don't know if anyone ever tried to install Linux in 1992, if you were doing that sort of thing. It was horrible. It was a mess of configuration files and bits and pieces. It really didn't work well. But over time, different people had different views as to how it should work. It fragmented, it broke, it became that many distributions in 2006. And the 2014 picture doesn't fit on the screen. That's why we stopped there. The three big ones, Red Hat, CentOS, and Ubuntu, those are the mature ones. Those are the ones that have stuck around a little bit longer. What we hope is that Hadoop doesn't follow a similar process, because it's difficult from an engagement perspective to say, there's all these different versions of it, which is the one that's right for me. So the next decision in the process is our reference architecture. This is what Hewlett-Packard and Cloudera pitch as being the base architecture. And it's a lot of tin. It's a lot of machines. It's too big. You are in a situation where you're still wanting to delve into something. You don't actually know how much you're going to be using this infrastructure. To spend that amount of money on infrastructure that big doesn't necessarily make sense. You want to be able to start slower. The other thing is, why bare metal and why not work directly on a VM? So we looked at this and said, we have a lot of VMs. This is something that we can provide. And in the market, we found these providers who provide Hadoop as a service using virtual machines. And the benefit, I think, the performance question, does Hadoop on bare metal run faster? Don't you like the term bare metal? It makes us sound much more interesting than if we were to just say computers. So with the virtual machines, the benefit is in the scalability. Performance, maybe it's faster on bare metal, maybe it's not. But from a scalability perspective, a virtual machine environment is much easier to deal with. If you only want to run some analytics for 3 months, you buy the infrastructure, you use it for a while, you buy the VMs, and then you shut them down. You're not left with this infrastructure, this legacy that you need to use to justify its existence. And the variability of big data means you might underspec it. You might come in with 20 servers, but actually you needed 100, and to get that through procurement is going to take an equally long time. So virtual machines make sense in this space because of the nature of big data. Just out of interest, a lot of this stuff runs on hypervisor. Our cloud platform also runs on hypervisors. But there's a new emerging technology that's going to deal with the performance problem quite well, and it's known as Linux containers. It's a whole talk for another time. This is something that we're going to be looking at, but the two companies to focus on if you're interested in the technology is Docker, who are making nice wrappers around the container environments, and Altiscale. And Altiscale are providing Hadoop, the Hadoop platform onto Docker so that you can run it inside a Docker-based virtual environment. It's something that we're likely to adopt in future too. So the question that we also get asked a lot is, why you and why not Amazon? As an ISP, we have to think about traffic as well. We have to think about the fact that you've got this cluster, but you've got to get data in and out of this cluster. And it's not free to transfer data. There's always an inherent cost in moving data around, and there's also time. Those are the two things that impact your ability to use it. So in the design, we had to put it in a place where it's possible to get data in and out of the machines quickly. So, because if you have 100 times the data, you have 100 times the problem. And we designed it to be in the data center where our other data provider customers sit, so they have infrastructure there. We've also put clusters in place that allows you access to some of the open data, so we'll give you access to weather data or something similar. Then security is also a big concern. A lot of people just assume that the cloud is okay, and the internet specifically, so the World Wide Web, it's okay to put your data in there and to do your analytics. But we have certain requirements. There's the POPI Act, there's corporate governance. There's some specific issues that a lot of our customers will have that they're not legally allowed to put this information on the World Wide Web. So we had to make a choice strategically where to put it. We have a couple of different cloud environments, and the environment that we've chosen is known as our virtual data center. It has the ability to integrate on a networking level the MPLS component of your network into that particular cloud. So you get the benefit of the infrastructure being in the data center, connected to all of those other services, but at the same time it's restricted. It can't see it. It's physically, logically separated on an IP level. So taking all of that into consideration, this is the final architecture we've come up with. It is something that we've tested internally to make sure that it works. It's something that we've tested with clients to make sure that it meets our minimum viable product requirement. And I've also spoken to other Hadoop nerds in the industry who understand some of the implications and have gone through similar builds to understand what goes wrong. You have to run 4 machines. You can't run. I know there's those single VMs that a lot of the distributors will issue for you. They're not useful. You need to actually try something slightly bigger. 4 is the minimum. It's 1 name node, 3 data nodes. Across that, we're running CentOS 6 and Cloudera CDH5. We'll probably bring out a pivotal version fairly soon. It's 4 CPUs per server, 32 gig of RAM, and 1 terabytes worth of storage across each server. And it sits inside our virtual data center. And specifically, this provides us what we consider to be the migration path. So it's an uncertain environment. If you're a CIO or a CTO in a company and you've been given big data as part of your strategy for going forward, so for the next financial year, you have to investigate big data, and we see that a lot. You're going to come to the point that you want to do something that looks like Hadoop. And it's still uncertain. You don't actually know how much you want to commit. You don't know whether this is something that's going to work for you. So what we think we've crafted is something that you can get to your starting point, put some data in, run some analytics on it, and see if it's actually giving you meaningful results. If what you get back makes sense and it's something that you want to use going forward, then you can start to scale up. You can start to add to it. You can start to put in more data, add more clusters, and eventually go into the data center with a nice big metal, big tin, bare metal implementation like that. Thank you very much.